I hope you can hear me. Right. Now we are here with the worksheet 1 discussion here. So we have set of questions. Question 1, 2, 3, 4, 5. There are 8 questions here, right? So let's discuss about this. First question, which of the following is true regarding quantum numbers? The first statement, the energy of all orbitals of an energy level are same. Now you have n equal 1, let's take n equal, no, let's take n equal 2. In that you have 2s and you have 2p, and then you have these things are there. This one is not equal to this one. No? The energies are different. If you take 2p orbitals, there are 3 orbitals like this. So in that 3 orbitals, these are equal energy, but this is not equal to the s orbital. This is not equal to the s orbital. Now s orbital is a sphere, and you know that. So first statement is wrong. Then the second statement, 2 electrons can have same set of 4 quantum numbers. This in rare occasions is wrong. That one can't be true. Not in rare occasions, it can never happen. When n equal 3, the value of L can be 2. Yes, Nick. When n equal 3, what are the possible L values? You can have 0, 1, 2. Right? 0, 1, 2. So you have s orbital, p orbital, and d orbital available. So that statement looks correct. When the value of L equal to the value of m sub s can be minus 3. Now this m sub s is equal to plus or minus half. So that one is wrong. When you consider 2 energy levels, the s orbital of lower energy level have larger energy than the s orbital of higher energy level. Then 1s has lesser energy than 2s. That is what they are saying. So lower energy levels have lower energy than the higher energy level. Right? Higher energy level, lower energy level. So that statement is wrong. So answer is answer 3. Next statement, next question. The number of electrons in manganese atom is 25. That have quantum numbers L equals 0 and m sub L minus 1 respectively are. Right. L equals 0 means what? Right. Let's write the electronic configuration 1s2, 2s2, 2p6, 3s2, 3p6. Now how many? 10, 18. You have manganese 25. That means 3d5, 4s2. That is what you have. Right. They are asking for what are they asking? L equals 0. L equals 0 means you can take the s orbitals out. This one, this one, this one, and this one. So how many? There are 2 here, there are 2 here, there are 2 here, and there are 2 here. So 2 and 2, 4, plus 2, 6, plus 2, 8. So you can eliminate the first answer and the last answer. It should be 8. Now this answer, and this answer all have 8. Now let's look at the m sub l minus one thing. Okay, m sub l minus means what? It should be either p orbital or a d orbital. It should be either a p orbital or a d orbital, because this is -2, this is -1, and this is 0, this is +1, and this is +2. Same like that, this is -1, this is 0, this is +1, right? Only p and d orbitals have them. S orbital cannot have that, right? It is only having 0 of m sub l, right? Then how many? They are asking number of electrons, number of electrons. So total number of electrons. So you have to take all the p orbitals and all the d orbitals. So when you take all the p orbitals, you have this one, you have this one, and here 3d5. Don't forget, it is 3d5. So here 1 electron, here 2 electrons, here 2 electrons, 2 plus 2, 4 plus 1, 5. So the answer will be 8 and 5. So third one is the answer, right? Third one is the answer. Now I have to erase this thing. Right. So what was the answer? Answer number 3. Answer number 3. Next question. Now we did this question in class, somewhat similar question. De Broglie wavelength of a neutron traveling with a velocity v is lambda. If the kinetic energy E of this neutron is increased 4 times the new de Broglie wavelength, right? We learned the equation E equal half mv squared. The mass of the neutron cannot change. Mass of the neutron cannot change. The kinetic energy is E, okay, is increased 4 times. You increase this 4 times. To increase the energy 4 times, you have to increase the velocity 2 times, because it is inside the square. So 2 square is 4. So velocity should be doubled. Velocity should be doubled, right? So if velocity is double, let's see what happened to lambda. Lambda equal h over mv. Lambda is inversely proportional to the velocity. That means when velocity doubles, lambda becomes half. That means you have your answer number 1. You have your answer number 1, right? The next one, I'm not muted, right? The maximum number of electron pairs of an atom that are associated with the principal quantum number n equal 3, right? The maximum number of electron pairs. Look, electron pairs. Electron pairs means that they are like indirectly asking about the orbitals. Now I taught you the equation. You have to take n squared. To get the number of orbitals, you have to get n squared. So it is like this. If you take n equal 3, if you take n equal 3, what is 3 squared? Let's try it. What is n squared? It is 9. What is n squared? 9. You have 3 s orbital, that is 1. And then you have 3 p orbitals like this. Okay. Then you have 5 d orbitals like this. You have 5 d orbitals. 1, 2, 3, 4, 5. Then 1, 2, 3, 4, 5, 6, 7, 8, 9. They have 9 orbitals. There you go. They have 9 orbitals. Focus like maximum number of electron pairs. They are asking maximum number of electron pairs, right? So it's answer 5, right? The visible spectrum of hydrogen is observed. This is an AC Balmer series. Next question. The green light of wavelength 4.42 times 10 to the power -7 meters is observed in the emission spectrum of hydrogen. The energy of 1 photon of this green light, right? 1 photon they are asking, so it is going to be easy. You have to just apply E equal HF, right? E equal HF. Frequency you can write another way, like V equal F lambda. F equal V over lambda. That means E equal H V over lambda. equal hv over lambda, right? You know h value 6.62 into 10 to the power minus 34 joules second. That can, you know, velocity is like speed of light, because it is a photon. Speed of light 3 10 to the power 8 meter per second, and you know the wavelength. You can substitute and get the answer. I won't get the answer now. It's like just calculation. You can use a calculator to get it, or whatever. Don't use calculator. Use a logbook or something and simplify and take your answer. Right. Right. Seventh question. The sets of quantum numbers associated with the last two electrons of an atom in an element are 300 plus half and 300 minus half. The element is. This one, look, will you now the sets of quantum numbers associated with the last two electrons. Now let's like analyze the quantum numbers here. Let's analyze the quantum numbers here. Now you can see which color am I going to use. Red color, let's choose. Okay, n equal 3. This is the principal quantum number. Now this is the address. I told you in the class. Now this is an address of an electron. There are two electrons here. They are saying last two electrons. Their address is only here. Right? 3s. This is L value. That means s orbital it should be. S orbital m sub L value only value is 0. That one also okay. And then s orbital, you have only one orbital like this, right? That one plus half and minus half. You have plus half value and you have minus half value. That means there are two electrons in the s orbital and it is n equal 3. Now look at your periodic table. What is n equal 3? Magnesium, not magnesium. N equal 3 means the third periodic table. So third periodic table, there are two. You have two what you call electrons. Electron, that means one electron pair is there. That means it should be 1s2. There are two electrons here, so it should be magnesium. Answer is answer number 3. This one, past question 8 one. Lamp produces 6 joules of energy per second in a blue region of wavelength 470 nanometers of visible light. For how long should the lamp be lit to generate 1 10 to the power 20 photons? Now I will wait. How do I? Can't I put a notepad or something here? Can't I color this? Can't. Right, let's forget about it. Let's forget. Right. I'll take it. Where should I take it? Okay, now look, let's do it here. Right, people, they are saying like joule per second. They are only saying the joule per second value. They are saying the joule per second value. Yeah, it's not coming on. They are saying the joule per second value. Look, 6 joules of energy per second in the blue region of 470 nanometers of visible light. Energy per second means this is actually joules per second. They have hidden that fact. They have just hidden that fact. Right? You have to. They have to take the pencil, mouse menu, draw. It's not there. Right. So this is actually joules per second, hidden value. Hidden value is joules per second. That means 6 joule per second. When you multiply by certain time, you get a certain energy. You multiply joule per second by a second value. Let's say you are multiplying by 10 seconds. 6 into 10, it is going to be 60 joules. Why? This is joule per second and this is second, and per second and second cancels off, you get a joule value. right? 6 joule per second is going to be here, right? So in the blue region, now you know the equation E equal HF, and HF we can write in the previous one also we did HV over lambda, you can write, right? HV over lambda. So this is a energy. Now this is a joule per second and this is a second value. So you have a joule value. That means you have energy. You know the energy now, right? Actually, you don't know the energy. You have to find the time taken, right? Right. Now you have to write the rest of the equation like HV over lambda. H value you know. V value, that is going to be the speed of light, because these are photons. Speed of light, you have to write here speed of light. It is actually not this, it is c over lambda value, you know, 470 into 10 to the power minus 9, right? That is easy. Hurry, easy job. You know the C value, you know the H value, you know the wavelength, you know the energy per second. That means you can find the time here. You can find the time here, you see, right? You will get some value here. I won't do this, right? It's a calculation thing, right? You can get the T value correctly here after applying to this equation, right? So that is the worksheet number 1. I hope you have completed that. Next, let's meet with the worksheet number 2, right? Never, I mean, the motto I should say, you never fail until you give up, right? Like, don't stop trying. These are worksheets, very easy worksheets. Actually, this is unit 1. Make sure you do like the worksheets every day. In the class, we are going to discuss the theory part and some basic questions. And then in these worksheets only, we are practicing questions. MSQ also will be started. So let's go with that later onwards, right? Right. Now, shall we stop now? Right? Let's stop the meeting. Okay, let's stop the meeting now. See you.